I've been involved inside Mental Graphics with the development of the coverage database that we have, and I've also been involved in the standards process. So I was there from the very start, so kind of had two hats here. And what I'm going to talk about today is, firstly, I'm going to talk about verification management and the onus on data management. So I'm going to talk about that in some depth. Then I'm going to give you an overview of the UCIS database and the API. And then finally, I'm going to talk about some of the emerging solutions that are the enablers of the UCIS, what we've done inside Mentor, and obviously some of these other talks that are happening today. You'll see where the UCIS is coming into use to make even more solutions available to the industry. So I'm going to first of all start off with typical VM requirements. Basically, you start with a design spec, develop a test plan, and then you go through the verify and refine, analyze type loop. And if we look at this flow, there's different aspects there that need to be managed. The process needs to be managed. So we want to drive that with a test plan. We need full visibility. We need turnaround time in here for results analysis. So as we're going through the verification on our different engines, we need to be able to verify the results. So that's all process management. Then there's the data management, which has become a real overload. Design's getting bigger. The amount of data and the capacity that you need to store with this data. You need to handle complex relationships between, say, tests and coverage and verification tools, etc. And this needs to be both immediate to know where you are now, but also historical, so you need to be able to like trend over the whole process. And then finally, you need tool management as well to kind of bring in the automation. You're going to have multiple verification methods. You're never going to be able to get it done with one verification method. And these are the real tools that kind of help you with the repeatability and the automation and the control. So that's kind of a typical requirement. We're going to home in on the data management side of things. Back in 2005 now, Mentor saw the need for a coverage database to unify data. Basically, we had a simulator that output a different format for code coverage, functional coverage, assertions, and we really saw that as designs were getting bigger, we really needed to consolidate that so that we could build infrastructure and build tools around that. So we needed the storage, we needed the handling, and we needed the visibility. So basically, we went away, we did a lot of research, and we came up with a unified coverage database. And there's a lot of other requirements around that database, not only unification, but also the capacity and the performance of that database is important for not just storing and getting the data in, but also all of the reporting. And I'll talk about some of the aspects of the modes in the UCIS API for handling those sort of things. The database needed to have test analysis, so you need to be able to merge many, many tests together from lots of different runs of verification tools. Also needed a test plan tracking method to be able to get this closed loop I've been talking about. So we developed our unified coverage database with verification management in mind back in 2005. At this point, we had a vision for the tools that we wanted to develop, but we just basically started with the database itself and this open API. The open API itself is what we use to develop our tools, and this was the open API that was donated to UCIS, and that's what I'll come on to talk a little bit more about later. So that was done in 2008, and it was actually selected in 2009 as the basis for the UCIS standard. So if we look at the unified format for coverage, basically we have here scopes and bins, basically representing the different forms of coverage. There's obviously different types of metrics you can store, and the way that the scopes are put together and the bins are put together kind of mimics how the metric looks inside the database. Then also in the database there's the ability for the test record or history section, which keeps all the information about the verification run. So about how the tool was set up, where it was run, who ran it, how long it took, all of that kind of information. But this area of the database also allows you to merge multiple test runs together and keep the history of all of that information. So that information is all in the database as well. And then you can actually associate each of these runs of a verification tool or test with the coverage bin so that you can do all that kind of test association analysis. that's the database as well. And then finally, these scopes that I was talking about, the scopes can be HDL scopes and coverage scopes, but the scopes can also be test plan scopes. And this allows us with a tagging mechanism to tag the test plan and the actual coverage objects in the coverage hierarchy and form test plan tracking tool. And this is the basis of the test plan tracking that we have in our tools today that's native in the database. So we went off and we developed a core set of utilities. The UCDB, which is the binary database inside Questa today, can be accessed with either the old UCIS API, the old UCDB API or the UCIS API. So it basically is able to be accessed by both. We don't mind. But what we've actually done is, not everybody's going to be wanting to use a C API. We had to develop a whole set of tools around that. And what we have is we have a whole bunch of CLI or command line interface tools that sit around our database that have been written on top of that API that are ready for you to use to rank and merge and do HTML reporting, text reporting, talk to the test analysis or test record structures in the database, and even do some editing and creation directly from the command line. And then on top of that, obviously, we then look at the higher level tools for process and tool management that I talked about in the requirements. So basically, you've got your data management with the core utilities that plug into the database. But then we have the higher level features that we built around that database, which is basically the test plan tracking tool, where you can use a Word document or an Excel spreadsheet, any kind of document to actually do your test plan tracking. Trend analysis to be able to do your progress reporting to look at coverage and objects over time. Results analysis, which is a whole functionality for looking at messages that are coming out of multiple verification tools. And then finally, we have our run manager that sits around the whole tool that can basically do the run management, run all the multiple verification tools, and give you the control and the repeatability. Can do automatic ranking and automatic merging based on the results from each of the verification tools. So it's basically a hub around this database that we've developed. So let me talk a little bit more now about the UCIS. The UCIS was a subcommittee that was formed back in 2006. Initially a guy called Richard Coe, who worked at the time for D. Shaw, was the chairman of this group. And basically what Accellera's policies are is to actually transfer what's developed inside Accellera into the IEEE, and this has happened in lots of the standards that you probably know today, to do with Verilog and VHDL, SDF, all of these kinds of standards. There's approximately 130 members of Accellera, but about 18 member companies are involved in the UCIS process. And actually after the actual standard was ratified, Alan Hunter took over chairmanship from Richard Coe, so he's the arm and he's the current chairman of the group. So what the initial goals were to identify interoperability opportunities, a big area for actually defining standard coverage models so that it made it a lot easier to be able to exchange ideas between tools, so that you actually had coverage models that are defined. Look for a standard way of exchanging that information from those data models, and really, and that's kind of what we're talking about today, is to encourage both the user and the EDA industry to actually advance technology for coverage in this particular area. So if we look at the database itself and give you a quick overview of what it looks like, it was actually released back in 2012, so it's about 18 months ago now that the UCIS standard was released. It's a generic database, so that slide that I showed you with the scopes and bins, that's exactly how the database is made up. On top of that, you have attributes and flags that kind of decorate the scopes and bins to kind of give the characteristics of the different metrics. On top of that, there's a full exclusion mechanism, so you can exclude coverage at any level within the scopes. There's test association, so that you can associate each of your tests with the bins that cover the count, so how many times that particular coverage metric can hit. And there's also a tagging mechanism, which is like a grouping mechanism that allows you to associate different parts of the hierarchy with different coverage. And that tagging mechanism is actually predominantly used for test plan tracking, but it has other applications as well. So the UCIS defined all kinds of coverage data models. So we basically took the data models that were already in the UCDB and added to them with all of the participants in the standardisation. So we brought together all of the different metrics that we saw out there in the industry, as well as all of those metrics that we had. Because it's a generic database based on bins and scopes, etc., you can also extend it as well. So any coverage metrics that we didn't think about can be extended within the database. And this is kind of an important aspect, is the streaming and in-memory access. I talked about some of the requirements for coverage in verification tools, and that's the fact that you want to get stuff quickly into a database, but reporting-wise, you need to be able to access that data very quickly. And the different requirements for getting the data into the database and actually reporting out of the database has a need for different types of modes of access. And the UCIS has both streaming and in-memory modes, which I'll talk about in a couple of slides' time. An important thing to note also is that the implementations are not binary compatible. So it's the API that's been standardized, not the actual implementation of the databases. Again, I'll talk a little bit about that when I talk about interchange of data. So the original UCDB routines, probably about 60% of it is still the same as it was when we actually donated, so they just had a name swap. But we did actually look at some of the areas of the database. There was a big change to all the iteration routines that iterate around the objects in the database. And the reason for this is we kind of changed it. If you're familiar with the VPI access iterators, we kind of changed it so that it kind of fell into more line with that. So it's kind of better known way of iterating around objects. We also introduced some optimizations to the property interface inside the database to improve things. And then there was a few additions to the original UCDB where we introduced a universal object recognition to make it easier to actually recognize particular objects in the database. There's a formal extension that was added to the database, which is a whole bunch of new routines for storing and accessing formal type data, because it kind of differs from simulation, and there's a whole bunch more information that needs to be stored. And then finally, there was also an XML interchange format that was added to the spec as well. So there were a couple of exclusions from the original UCDB. The test plan scope was excluded, and some of the calculation methods, the standard calculation methods inside the UCDB were removed. And this wasn't down to the fact that it was deemed that they weren't needed. It was just down to time. Basically, the process for getting the specification out there took a long time. We needed to get the first spec out there, and this is sort of work that we'll be doing when we go to 1.1 or 2.0 to look at some other areas that time permitted. So if we have a quick look at SP functional verification and kind of show you how that gets represented inside the database. This is a cover group, a standard SP cover group, and this is a way of viewing that directly using the in-memory mode. So this is basically a cover group browser that works directly off the cover group. And basically what happens, for the cover group, it generates a UCIS cover group scope for each of the cover points and crosses, generates scopes for those, and then the standard bins generate bins with the bin counts and all of the standard weights and goals and attributes that get annotated on top of this. And this particular browser here, because it can actually look at the data, it's got random access to it, and this is why it's actually using the in-memory random access mode. I wanted to kind of show a couple of examples of both the in-memory and the read streaming to kind of give you an idea of what they're really for. With the in-memory mode, what I did was I took this application that basically outputs a CSV file. So basically what it's going to do is it's going to translate information in a binary coverage database and output a CSV file. So this particular application has random access. You could probably argue that because it's a reporting function, it doesn't really need random access, but I just wanted to take the same application and show you the two examples side by side. So this is the standard UCIS code. We open the database. There's a print statement here that's printing the information that we're going to output about each of the objects in the database. So we're going to output its name and the source code that it comes from, the line of code it comes from, and its weight and goal and counts. And then this particular routine does all of the user calling and basically calls these iterators on each of the objects in the hierarchy. And you can see here that the iterator basically goes through a while loop. The while loop gets tested for each of the different objects. So you can have all the different kinds of objects that are inside the database. And then finally, the routine's recursively called, so that it basically recurses down to the hierarchy. And then each of those calls to the process scope will just print out the information about the scope. So you get your CSV file. So this uses iterators, and obviously there's a performance payoff because all of the database gets loaded into memory and you've got random access to it. The streaming mode, however, basically works off of setting up callbacks. We've got the same example here, but this time we open the database, we set up a callback on the database, and then basically what happens is each of the objects are streamed through in the interface to the database, so we're not iterating across them anymore, we're just streaming through everything. And then basically this callback routine is called each time on the scopes and the bins, and you extract the information the same way. The big difference between this is obviously it's very memory efficient, because at one time in time you've only got a certain amount of information in database, but it's up to the application to kind of gather information if it needs to reuse it, whereas the in-memory mode kind of gives you access to the data all the time. So give you an idea of how you create applications. You've got the C code that basically you build up your application with the C routines from this header file, and then we supply, or a shared library is supplied, which you compile up that library with, and then you get your coverage database and you call the application that you just compiled up, and that outputs the CSV file in this particular case. Very, very straightforward. This is a standalone application that you can just then run on any coverage database and get the information out of. If I wanted to swap my vendor that still supported the UCIS, then all it is swap out the shared library, get the database from the vendor, and you're using exactly the same API routines to access that data and output the data. So it kind of shows how easy it is to swap vendors using the same API. If we kind of look at the tool landscape out there, obviously there are a few vendors that support the UCIS like Mentor do. There's also an XML schema that was part of the database that allows access to the data. But there's also tools out there that basically are custom format with custom APIs. And the biggest question that people have got is how do we transfer data between them, because that's really what we want to do. So the idea here is that if you've got two vendors that use the UCIS, they actually have an identical schema because they're basically using the same scopes and bins and the same terminology between their databases. So it's very easy here to be able to put an application between these two, just like the application with the CSV that I just showed. But what we do here is we can basically exchange the data through like a UCIS to XML, XML to UCDB, to UCIS. Right? So here, the important thing is not only do we use compressed XML between these to do the transfer, but also there could be data manipulation that's needed. Because vendor of tool 1 and tool 4 might not actually support exactly the same types of metrics. So this particular application that sits between them might have to do some form of manipulation. And this is something, again, that Mentor a couple of months ago, we actually donated, again, the UCIS to XML C code to Accellera. And what we're trying to do inside Accellera is kind of build up a library of routines that can be used by UCIS implementations. So just to quickly look at some of the solutions that this means that we can build using the UCIS inside Mentor, because we've had the UCDB around for such a long time now, we're able to interface multiple engines, be it emulation, formal tools, analog simulation, all of these tools inside Mentor use the UCDB and hence the APIs to get their data in and out of this database. On top of that, we have tools like RecTracer that does requirements traceability. And again, because that plugs into the database with a test plan, you basically get support for all of these different kinds of verification methods in being able to do requirements traceability with design requirements, etc. And then finally, because we've built the common management with verification management, you get your tracking and your trending and results analysis for the complete tool set as well. That gives you an idea of kind of overall things that you can build inside one company. So obviously when you've got third-party tools coming into it, you can build an even bigger ecosystem. This is an idea of some of the complementary technologies that we've used inside Mentor. This is a traditional code coverage closure flow where you've got a certain number of coverage objects after running code coverage, in this case in Questa. And what happens is manually you go around this loop of reviewing the code coverage, looking at why something's uncoverable, maybe it's unreachable. And for that case, you have to write these exclusions. So we might write 12 exclusions, apply those back to the database, obviously forces our code coverage numbers up. Likewise, they might be coverable, and we've got to go and write more tests to be able to cover these objects in the database. And again, as we go around this traditional loop, it's time consuming because everything's a manual process. I mean, if you're taking 10, 15 minutes for each cover object, etc., and you've got thousands to cover on, that's man-months of work to be done. So here what we do is we actually use cover check, which is basically formal technology that can read data directly out of the database. And then what basically happens is, because within Mentor our front ends are absolutely identical, so any coverage objects that the simulator is putting into this database, our formal technology can read because it uses the same front end. And then basically what happens is Questa cover check will look at those uncoverable objects and automatically generate exclusions. So there's no more of this having to go in and analyze each one by one. This is done automatically by a static formal tool. Likewise, on the other side, any coverable objects, it will actually direct you and help you by generating waveforms to how to get to those particular objects to be covered. So it helps you write the tests. And as I said, this can save many man-months. We've had a number of customers that have saved many man-months of basically using these two technologies together. So just in summary, Mentor's committed to these standards. We've made a big, or we're a big part of the standardization process. I believe that the UCIS is starting to enable solutions, and hopefully with the other presentations that you see today, you'll see that that is actually starting to happen. And Mentor are well posed there with their verification management tools built on top of this infrastructure. So that's my presentation, and if there's any questions.
Any questions? You have to repeat the question. You mentioned that exclusion waivers. That format.
It hasn't been. No. Yeah, the question was the format for waivers and exclusions part of the UCIS process? And no, it wasn't. There's basically the mechanism for storing exclusions in the database, so it's just set as a flag in the database. Other tools can do, like within Mentor, we've not only got that flag, but we also have an attribute that kind of allows you to pin a comment on top of it as well. And that wasn't part of the standardization process, but it's part of the generic database that any tool can do whatever it wants to do. But it's probably something that could be done in the future. There's a whole raft of things that could be done with the standardization process. But yeah, any questions from around the world? We can supply email addresses or whatever, so if there are any questions that anybody thinks about after the session, after we get to network here, or even when you leave, I'm sure we can provide email.
Just after a clarification of what you meant by, so some of the things you said were excluded from UCDB in UCIS. You said you excluded test plan scope. Could you elaborate what you mean by test plan scope?
Each scope's inside the database. There's standard recommendations, so like an HTL scope and a different coverage type scope, like maybe a branch scope or a statement scope, etc. Well, the test plan scope type was just excluded from the standard, and it was just because it was thought that it's another great big long subject to go into test plan tracking, and there just wasn't time to get that done before we wanted to get the first release of the standard out there. So it's definitely something that's on the list for future standardization. And in my own mind, you know, from a mentor point of view, just including that scope name as a test plan tracking scope name gets you test plan tracking. But it's just with all of the people involved in the committee, you know, it's not as easy as that.
So you showed another diagram with linkage of rec tracer and test plans using UCIS data. What material difference does excluding the test plan scope actually have in usage?
It just means that from using the UCIS API, you wouldn't recognise it as a standard scope, and you would have to, you know, within Mentor, we have an identification of a standard test plan scope. So if you use the UCDB API, you will understand it as a test plan scope. If you use the UCIS API, it will come back as an unknown scope. That's the only difference.
Okay, all right, thanks.
Okay. Yep. Another one?
You have to repeat the market again. This was about, you showed an example of code. Is that within the scope of UCIS?
Yeah, the question was, did UCIS address code coverage metrics? And absolutely, the data models inside the standard support all of the metrics from all of the vendors. So I mean, if you look at, there are differences obviously. You know, Mentor support something called branch coverage, Cadence do block coverage. You know, some do line coverage, some do statement coverage. There are different metrics, but all of those different metrics were defined in the data models in the specification. So, you know, if one tool doesn't support that type of metric, because it's made up of all of the scopes and bins, you could still transfer that information into the second database, but the application would then have to try and make sense of what it really meant. Can the tool also manage actual test life cycle, rerun of a failure test, or analyse the test failure themselves, not just the coverage? Well, that's the verification management tools can do that, basically with the run manager here. So this looks after flows, etc. So it's a high level. So that's got nothing to do with the UCIS itself. There's just certain aspects of the database here that the run manager can take information out. But obviously, you know, this gives you scope to build all kinds of tools based on tests and flows.
Okay. Thank you very much.